He was somewhere.
Hedgehogs digest chemical compounds, proteins, fat, vitamins, and minerals.
Essential to fish and other mammals, including us, are these 9 essential amino acids. Some species, dogs for example, have additional amino acid requirements such as arginine. These dietary amino acids are generally required due to the inability of the creature's body to synthesize it for themselves. Hedgehogs require the 9 essential amino acids plus collagen. They require these other compounds, chitin, which is very similar to cellulose and is a structural compound found in beetles and other insects. Where cellulose has a hydroxyl group at the carbon 2 position of each glucose unit, chitin has an acetamide group. Omega-3 and omega-6, these are fatty acids consisting of a carboxylic acid and a hydrophobic carbon chain, with the first double bond starting at the 3rd and the 6th carbon from the omega carbon, respectively. Vitamin D is another one they require because of their nocturnal habits. They don't get enough sunlight to produce vitamin D themselves. They also require minerals, calcium, phosphorus. These are good for strong spikes, I imagine. Iron, magnesium, zinc, and potassium.
Wow.
Say hello. No cheese for me.
Here we have chopped up some pieces of sodium metal. The more surface area the better. I was a bit lazy. I imagine a cheese grater might have worked for this. The sodium is then sandwiched between layers of potassium ferrocyanide. One important step is to ensure that your potassium ferrocyanide is anhydrous. Not just because any moisture will react with the sodium. At the temperatures we are subjecting this to, the presence of moisture will cause hydrogen cyanide to be released. When this is dry, a plausible byproduct of the heating process is that small amounts of cyanogen gas may liberate. Time for a correction. Cyanogen is not likely to form either. Cyanogen can form at any pH, but an oxidizer is required. Sodium is a strong reducing agent. It displaces the ion and locks the cyanide into an ionic salt. From an alkali salt, hydrogen cyanide fully liberates in contact with the mildest of acid. Hydrocyanic acid exists below pH of 6.
So I hear you're in crude colors. Life in the neon lights. Energy. I have some
Now that our sodium has reacted, we can pour our melt onto a piece of aluminium foil, or for you Americans, aluminum. You might have noticed the sodium catching on fire earlier. That was it reacting with oxygen rather than our ferrocyanide. That primarily creates sodium peroxide, with some sodium oxide. Both are basic. The peroxide can potentially oxidize the ferrocyanide to ferricyanide, which can then react with the sodium, releasing toxic gases. However, this should be negligible, so long as you're in a well-ventilated area and you're not breathing in the fumes. That way, if any fumes are generated, they can dissipate well enough that nobody is going to be harmed.
Get the stir bar spinning inside. Clamp it up.
Danger.
Let's talk more about cyanogen. Although this is not hydrogen cyanide, its lethality only differs in how easily the body absorbs it. Thankfully, cyanogen is a respiratory irritant. Not a warning, but a foreshadowing. The impending dizziness and gasping. Cyanide bonds to the iron within cells that are meant to grab oxygen for cell respiration. As your body begins to suffocate on a molecular level, your heart and your brain will suffer first. You must seriously contemplate your options, as the fight to preserve mortality is on. Do not wait for symptoms to worsen. Get some fresh air. Don't induce vomiting.
Call emergency services.
This is a top-level emergency. If it is not possible to get to a doctor, a hospital, or a paramedic, if you have 12.5 grams, 50 milliliters of a 25% sodium thiosulfate antidote, and the syringe. Administer this over the course of 20 minutes, followed by 300 milligrams of sodium nitrite, 10 milliliter dose of a 3% solution.
Once cyanide is swallowed, it is absorbed into the bloodstream almost instantly. By the time you drink a second substance, the cyanide is already moving toward your brain and heart. Drinking bleach will only damage your digestive tract.
I need to find my cigarettes.
Do not wait for dizziness or gasping to worsen. Sodium hypochlorite is used in laboratory settings to oxidize cyanide into less toxic cyanate. However, attempting to quench cyanide by drinking bleach is life-threatening.
Your instinct won't afford you much protection, as once it is inhaled, it turns into hydrogen cyanide. No, it's not your stomach acid. It reacts with reducing agents found within blood and tissue, such as organic sulfur compounds known as thiols that are found in protein. These break the carbon-carbon bond of cyanogen to produce two cyanides, which then go on to react with hydrogen. If neither sodium or potassium ferrocyanide is available, ferrocyanide can be obtained by reducing its more oxidized ferricyanide salt using hydrogen peroxide. Interestingly, depending on the pH of the solution, hydrogen peroxide can either reduce or it can oxidize, making it easy to convert ferri to ferrocyanide or ferro to ferricyanide. Because the cyanide is strongly bound to iron, it is not hazardous. Here I am preparing two solutions. one with 6 grams of potassium ferricyanide and the other 1 gram of potassium hydroxide. Once they have dissolved, I combine them. And begin to add hydrogen peroxide. Dropwise. I didn't know the concentration of my peroxide, so I just did this step by eye. Once I think I added enough, I evaporate it down by heating it. I allow it to cool in a bath of cold water, and then I filter off the crystals. To get the anhydrous salt, this needs to be heated at 70 degrees. When gold is reduced in the presence of tin 2 chloride.
The gold particles don't dissolve. Instead, they form tiny clusters, so small that they are measured in nanometers. These tiny clusters change how light is absorbed and scattered, shifting the metal's iconic yellow shine into a deep, mesmerizing purple red. It is amazing to think that centuries before we had modern microscopes, alchemists were already working with nanotechnology. Andreas Cassius was a 17th century German physician and alchemist. In 1685 he published De Oro, a detailed work describing the preparation of the gold tin precipitate. He popularized the formula, the secret behind purple of Cassius. Nanotechnology, a field of science we didn't even know existed centuries ago. The pigment is known as the purple of Cassius, named after Andreas Cassius, a 17th century German physician and alchemist. While it was named after him, it isn't just a simple suspension of gold. It is a true nanoscale gold suspension.